Hello. Well, I promised the Bernoulli group that I would go through this last example in a video. I'll make this really short. I'm going to go through it quickly, just so you can kind of see mainly like how to find this kind of thing right here, this expected value of x times y. Okay, so just a really quick review. So this is from your handout, this example. X was the number of roommates in a suite in a residence hall, and Y was the amount of money charged for fines in the semester. So notice there's only 5, 6, or 7 roommates, and there's only fines of 100, 200, 300, 400. So just a quick review. If you wanted to find the marginal for Y, this might have been a previous part of this problem. This would be the probability of y on its own. Put it in the bottom margin because the y's go across the top margin. And if you add all of these up down this column, you'll get like the probability of 100 is 0.34, and the probability of 200 is 0.18, and the probability of 300 is 0.18, and the probability of 400 is 0.3. Those add up to 1, by the way, as they should. And this probability of y, that's the marginal for y, okay? So if you wanted, first of all, so what I want to do is just real quick, just review how to find the expected value of y from a joint distribution, which would be something that's really the mean of y, which it's also called the expected value of y. The formula was y times the marginal, the probabilities of y, right, overall y values. So notice that'd be like 100 times 0.34 plus 200 times 0.18, right? So each value times their associated probability. And if you do that, the probability of y ends up being $244, okay? So on average, y will, the value of the amount of money in fines will be $244, all right? So now let's see how we do the expected value of x times y. Okay, so I wrote this formula here for the expected value of x times y. It looks a little different than the one in your book. All right, and it's just, I think it just makes more sense, okay, intuitively. What this summation means right here is it's the sum over all possible xy pairs. So this table, right, gives all probabilities for all xy pairs. So like this 23, right, is 0.23 is the probability of that you have 5 roommates and $100 fine, and so on, right? Okay, so notice there are 12 different xy pairs. Okay, so what we need to do is we need to take each xy pair, multiply the x times the y, and multiply times their probability. So if we're going to do this, the first xy pair in the upper right left-hand corner is 5 times 100. That's x times y times 0.23. Right, then the next is 5 times 200 times 0.10, right? And we would do that for all the pairs. And then like the last pair might be 7 times 400, right? We have done a bunch before that. 7 times 400 times 0.18. All right, and after we do all those, we'll get, actually it's unitless. It's really people dollars or something like that, but it's 1,488. These kinds of expressions are used in covariances and correlations and things like that. All right, so it's not hard to do. All right, I guess the main thing to remember is just overall xy pairs. All right, that's all I wanted to show you.